Let's see if we can figure out what the derivative of e to the x is. Well, of course, we always go back to the difference quotient. So we have dy dx equals the limit as h goes to 0 of e to the x plus h minus e to the x over h. We always go back to the definition, the limit of the difference quotient, if we want to find out what the derivative is. So now notice here, I could rewrite this way. I could say, well, this is the limit as h goes to 0 of e to the x, e to the h, just a property of exponents here, minus e to the x over h. And then notice I can factor out the e to the x. So here's what we've got. We've got the limit. This is the derivative, the limit as h goes to 0. And I'm just going to put, well, let me go ahead and give it its own limit here. The limit as h goes to 0. So what I've done is I've factored out e to the x. Okay. So I hope everyone sees that clearly. I have the e to the x here, e to the x here. I just factored it out and put it out front. So I guess let me put in an intermediate step here. This is the limit h goes to 0 of e to the x times e to the h minus 1 over h. Okay. And then I just went ahead and put the e to the x out front. Now, I didn't need to put a limit there because e to the x doesn't have an h in it, so it doesn't care what h does. So here's what we've got. Here is the derivative of e to the x. The derivative of e to the x is e to the x times this limit. So what I've got to do is figure out what this limit is. Now, I think the way I want to do it now is just look graphically at it. In other words, here's what we know. Our derivative, the derivative of e to the x, is e to the x times something. And that something is this. So we need to figure out what this something is. So we'll do that graphically and kind of numerically. Okay, so what I've done is I've put that little part in there, that e to the h minus 1 over h, in my calculator in the graphing, in the function editor, y1. And I used x as my variable instead of h just because x is what's most convenient here. That's the default. So I used e to the x minus 1 over x, and what I'll do is I'll increment x, or I'll look at the graph of this. So here we go. Here's what the graph looks like. Now notice, this is just that e to the x minus 1 over x, and we're concerned about what's going on as x goes to 0. And you can see it looks like it's 1. See? So these little marks here are in units. So this looks like it's in 1. It looks like it's 1. So we start to, this kind of gives evidence to support that. Now, next I want to go to my home screen, and I want to put in values. So I'm going to get this function y1 back, and I'm going to evaluate very close to 0. Let me do this. Let me open a parentheses, and then I will open a bracket, and I'm going to put in a negative 0.0001, something very close to 0, and then I'll put in a 0.0001, close to 0 on the other side. And then I'll close all that off, close my parentheses. Whoops, I didn't need to do that. There we go. And notice it looks like I'm, getting very close to 1 here. And actually, let me do this. Let me add some more zeros in here. Just, quit beating around the bush. Just add, maybe 3 more zeros or so. And then Let me see, I guess I got 6 zeros. There we go. Okay, and let's see what that gives us. 1.7, okay. Let me see. Actually, I didn't add a point there. Sorry about that. Okay, here we go. I got to put a point in there. That was what was wrong. Okay, and then I get a 1. Add that. Oh, look at that. It popped up a 1 there, a 0.999, about 7 nines over here, right? Let me go again. Let me add another couple of zeros over here. Second insert, maybe a couple more zeros. Oh, now it went ahead and called it 1 and 1. You know, the calculator just threw up its hands and said, oh, let's just call it 1. So this, together with the graph that we just looked like, it's pretty obvious that that limit is 1. So it looks like what we have here is the situation where the derivative is just e to the x, because we're thinking this limit is 1. And in fact, this is one of the amazing things about this number e to the x. The derivative is itself e to the x. Now, you have to remember, though, all the rules for differentiation still apply. Product rule, quotient rule, chain rule, all of that. So, for example, the chain rule applies. So maybe we have e to the 3x. Well, that derivative is going to be e to the 3x, that's the outside, times 3. The derivative of the outside times the inside. Okay, so we might have, well, what about this one? The derivative of e to the x squared plus 2x, something like that. Now, so remember, e is going to be, we consider that the outside function. So, in other words, remember, if you're trying to plug in a value for x to evaluate this function, what would you do? You would first of all find the x squared plus 2x, and then you would just apply base e to that. So we go backwards, and we're going to differentiate the e part. Well, that's easy because that just involves us rewriting it. No work. And then we take the derivative of the top, which is 2x plus 2, and there, we're done. Now, of course, you can put this together with the other functions. Now, we just have another rule to consider, another derivative. So let's suppose that we've got e to the 4x sine 2x, and we want to differentiate that. We want to find the derivative. So obviously we've got a product rule involved here, and plus the chain rule. So here we go. Let's look at this. We've got dy dx. Okay, so I'm going to take the derivative of the first, which is going to be 4e to the 4x. See, I just rewrote e to the 4x and then multiplied by the derivative of the top. Derivative of the first times the second. Okay, so here's that. Plus the derivative of the second times the first. Well, the derivative of the second, let me just go ahead and write down e to the 4x, because I'm going to take the derivative of the second times the first. Let me just write down the first. Now I can focus on the derivative of the second. It's going to be cosine 2x times 2. See? Derivative of the outside, the trig function, times the derivative of the inside. Now let's see what we've got here. We've got 4e to the 4x sine 2x plus, look at this, 2e to the 4x times cosine 2x. And there we have it. There's our derivative. So we have just added to our knowledge of derivatives the derivative for e to the x. And all the other rules and all that we've accumulated, those all still apply. This is just another differentiation formula.